Hello everyone. Oops, sorry, this is my first time to broadcast or stream. Sure. Uh, so no one is here yet, so I think this gives me more time for settings. I'll start in a minute, just to make sure that everything is going correct. Hi, there's a huge delay. Let me see if I can hear myself. So no one is here yet, so I can hear myself with a delay about 30 seconds, but it's okay. So probably it's not exactly streaming, but I'm giving a chance if anyone can, if anyone has a question while I'm streaming this. So yeah, the launch, rendezvous, and dock program in Simple Rockets 2. Many people asked me to explain how this goes on. So what you see right here is this is the capsule that I want to dock into the other station or other capsule. So if you can see here in these orange things, these are the RCS or CRS, reaction control system, RCS. Yeah. So I'll start with my biggest problem. In this capsule, you see here, this red light here represents the top or the astronaut head in this configuration. So it would be natural to think that this is down and this is left, but you cannot, or it's very hard for me, at least for me, to keep this craft oriented this way with the pilot's head to the top, especially if you're making a rocket. It's very hard for me. So when it rolls to one side or the other, like this, you get down from this one that was supposed to be only left. You get down and you get still a component of left as left to right. And here opposite component of left and a bit of down. So for this problem, instead of orienting my craft to have the pilot's head always up, I gave up and I said, it's okay. Whatever the angle is, I can get the components of up and down and left and right. And these RCS, I give them the components for that. So that was the first problem, and I will show to you how did I manage fixing it in Busy. Now the second problem is approaching the other crafts. Approaching the other craft in this manner. There's a range and there's a difference in altitude. I call this Z and this I call it Y. So my method to approach without hitting it or without missing it, or approach with a proper speed to get me there in the shortest time, is to make the velocity on the z-axis to be 1/100 of the range, and the same goes for the y, and the same goes for the x. The x is inside the screen, inside and outward of the screen. So this is the idea. I try to achieve that speed, and by the time I achieve that speed, I'm more closer, so that speed should be reduced. So instead of RCS forward, At a certain point, I start to RCS backward. Um, Maybe it's half the trip. I don't really exactly know. Doesn't matter. These calculations are performed automatically by the physics program. So now I'll move to the basic program. I have to stop sharing this, and I hope I succeed in sharing the Simple Rockets 2 successfully. Where? Um, yeah, share screen, application. Oh, I don't have the. Yeah, there it is. No, application window. Oh, I don't have it. How? Here's my Simple Rockets 2. Still trying to share it. All right, there I got it. Oh, have to be. Okay, so this is the program for the capsule. And I really skipped an important part here. This program is not rendezvous and dock. This program this program is launch, rendezvous, and dock. I have specified this way not to give you a wrong impression that I'm using orbit launch is a very important part of this. I have a timed launch with what I call a tracking radar. That tracking radar launch the craft at the proper time where it sends me like a few kilometers away from my station. So I'm still failing to share the screen. Okay, I think I have it here. Okay, I think you can see it. Uh, Most of this program is launch program. Um, this is not working well. My laptop is old and uh, Super Rockets 2 is heavy for it. So the program, I don't scroll to the top of the program, but in the stream I don't see any of that. I wish I could turn off this camera showing me, but I'm afraid that if I turn it off, it might turn off my audio too. So yeah, okay, here's the program. So the first of the program, if the mass is less than 8,000, will break. The craft is basically two components and for it to start. So all of this is scrub. Yeah, yeah. Throttle to zero. This means we are in orbit. The solar panels opens booster the RCS. So, oh, Rumpus, you're here. Paul Wheeler, smoking is bad. Yeah, I know. I'm sorry. I'm sorry to find simple comparing to. So I say X range, Y range, and X range here. This is the difference in altitude. Never mind the X, Y, Z axis. The names that I give here, they don't comply to simple rockets to PCI coordinates. So the X is difference of altitude. Nav position, that's my position from the center of the Earth, and the target position from the center of the Earth. And Y, this is the proper the proper axis according to simple rockets. Now, the Y range is what's the Y range? I think yeah, the Y range is right in it's very easy. And then I get the rate x and I calculations again and multiply by 5. So that gives me the relative speed between myself or my craft and the station. And then activation group, never mind this. Is just to display certain things. And okay, so then trans north. This is the translation north or south. I wouldn't call it left and right because as I showed left and right, it's now north and south. Uh, higher and lower. This is the trans high. Go up downward. And as you see here, the set this is the desired speed that I want to approach the craft with. And as you see, like it showed you previously, the X range divide 100. So the rate, that's the speed. So this means if I'm approaching the other craft very fast, this will be deducted from the desired speed. This when I get close, less speed. And then yeah, okay. So this set variable role, this what tells me the orientation of the craft, if it's left and right, just to get the components of the for the RCS. And then here's the translate right, left, right, up and down, not yet approaching the craft range. Long, I basically calculated the digital of latitude of the planet and to align it with the inclination. No, sorry. Yeah, this is the relative V, which is the my target velocity. Uh, just long range, and again, here's the equation for the speed. Here's I reduced the speed a little bit, but I didn't really than the I think it froze. I'm sorry for that. For right view, what I already said. From assume is 5 minutes. Uh, but first, let me show you. This is what I like craft talking about here. Craft together, or a craft and a module. This and in the program for elevation angle of the connector will or this the total, that's the you have to switch between the other command shift that is in this craft. It's two-stage rocket, and yeah, that's about it. So I'll get back to. I have to stop sharing this and get back to the main problems for docking or rendezvous and docking. And again, this is not orbital mechanics. I'm just using uh, that rudder to put me within few kilometers of the station. And once I'm there, it's very easy to approach and to dock. I'll share screen of the other diagrams that I made. Where it is. Yeah, so this is my craft front view, and this is here 1, 2, 3, 4 RCS, and this other four RCS in the rear side of the craft. So the first problem, that if this red light represents the top of the graph or the astronaut head, this is top, or the RCS would work in this way, uh, down, and this is left. But if the orientation is changed, and there's something that's going to happen beyond my control. I cannot control the orientation on the roll axis. It's very tricky and it's hard for me. So instead of keeping the orientation of the aircraft with the pilot's head up, I get the roll value, the angle, and then I get the components and tell the RCS where exactly do I want to go. So this was the first problem, working on the X and Y axis. For the Z axis, or for the approach speed of the craft, this is my craft and this is my station. This is the range Z, and this is the difference in altitude in Y, and I just keep my velocity 100, one of 100 of the range. And of course, I forgot to type here minus the relative speed that I already have. So if this Z is 10 kilometers, then I want my speed to be 1 kilometer per second. And of course, it takes, yeah, 1 kilometer per second, exactly. Of course, I will never reach that, sorry, 100 meters per second. Yeah. Uh, by the time I'm 100 meters per second, I'm more closer. So the new calculation for the speed is the remaining range minus my original minus the speed that I gained. I'm not sure if that's simple enough, but I think yeah, that's all. So if you have any questions, just leave it in the comment section, and I'll get back to you as soon as I can. Thank you all for watching. Bye bye.